Bum 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 bum. There we go. Got initial, teacup, rip base. What's up, guys? Glasses. Bonjour, hola. That one kid. What's up, that one kid? One's okay. All right. Oh, my sounds aren't working though, man. No, that's fine. What's up, shit? Ooh, I do need to watch the trailer. What's up? What's going on, Ramson? Sam, remind me of the trailer. What trailer was it?
What trailer are you watching?
I know. It's scary realistic, he says. Ooh. Something scary realistic. Always like to see.
But he sent a link, I think.
Yeah, I got it. I got it. Unrecord the official gameplay trailer. How long is this gameplay? Oh, this is a video game? This what? Nah, bro, dude. Oh, I think I heard about this. This got in trouble because, right? Because it looks like too realistic.
Yeah, this is kind of...
What? Oh,
There's
dude.
no way this is a video game.
It says it is.
Shots fired.
Looks like a video game. I mean, it looks like, yeah, this is like, this is what's messed up with society, dude. This is what's messed up because, like, we see too many, like, police body cam footage, and now they're making a video game out of it. Like, what?
It's a video game.
Wait, that's actually a video game?
Yeah,
It's
dude.
Unreal Engine, the new one.
Unreal
Bro, that
Engine
shit
3.
looks so real.
You know that this...
5, not 3.
Is it not 3? Not UE3?
3 is like,
Oh, it's
But
5,
where's
though. My bad.
yeah. UE5 is a nice one.
It's the new Fortnite is based on it, right? It's like Epic and Fortnite, Epic and Unreal, sorry, like own each other basically.
Mhm.
Damn,
Yo,
that
no,
is
that's
realistic.
actually crazy.
Might be
That's
on UE5.
that's like super
Yo, I
realistic.
thought it was just I thought straight up that was just a video, bro.
That's what I
was
said,
like, yo,
dude.
what the hell?
That shit looks like super crazy, dude. Yeah, this is the new Unreal
future
Engine.
of Unreal Engine,
We have Unreal Engine.
like actual
Yeah.
caves that we sampled.
Yo, they
and
some
reproduce
nerds,
them.
I ain't gonna lie.
Runs on our chaos.
Oh,
physics
nerds are what
system.
make your video games
Here
work.
we are using it to
There
accurately
is a weird
simulate
part
larger
about this,
bodies
though, and
of
Well, I
it's
need
rock.
that,
to
like,
upgrade my
nobody's
gaming
actually
laptop.
seen any gameplay other than that trailer.
That
That is
trailer,
it.
that trailer is scary, dude. It's like scary good. I wonder what
Yeah,
that's gonna
they
like.
haven't shown like anything else other than exactly that.
What is that gonna do to like humans, dude? What like we don't need to be like watching.
I was looking at the FAQ for it, and it was
Yeah.
a bunch of veterans all saying that they cannot play this game because how
Yeah,
bad
dude,
of
that's
a
like
trailer.
super like PTSD, bro, dude. No, we've gone too far. Gone too far as society, dude. There is a demo
Imagine
level,
Arma
Sam
in
says.
Unreal Engine. That would be horrible.
Imagine what?
Unreal Engine 5 with,
Arma
like,
and Unreal
VR,
Engine would be
bro.
horrible.
Oh my god, bro.
Say that again. Initial what on Unreal Engine 5, dude?
Arma, the
Oh
Milton.
yeah, I remember Arma. Yeah, that used to be Operation Flashpoint, right? Like way back.
Yeah,
Yeah, that
and
was a
then
dope
it
game.
became Arma 2 and DayZ, and then Arma 3,
Yeah.
and then now Reforger.
Cool.
Yeah.
Sam says there's a demo level, dude. Like, what type of video card do you need to run that?
5090 Ti.
What? 5090 doesn't even exist yet, dude. What?
Bro, what if they had like Unreal Engine 5 with VR, bro? Like, nah.
They
Nah,
said that they
dude.
aren't gonna do VR support for this game because then it would get real bad.
Thank you, bro. I'm talking about like just in general, like anything
Like,
VR.
dude, you're gonna
bro,
have to
it's,
start like having,
Unreal Engine
you know,
5.
buy the Vault pack. It comes with like 5 free sessions with a therapist. Like, what? That's gonna fuck some kids up, dude. Oh
For
man,
real.
dude. Okay.
Do you
Anyways,
see what
Our
kids
dad
play
kid
today,
is
bro?
gonna
That
fuck
ain't
some
shit.
people up.
I know. What's up, Rampton?
I said our dad kid's gonna fuck some people up.
I know, right, dude? Fuck.
Yeah, this is like combat training essentially.
The stuff kids
Yeah.
play already, that's nothing.
I know, but like, dude, it just looks like too. I don't know about the whole like body cam footage like thing. Like, I don't know. It's like super weird. Yeah, it's
Yeah,
like
that
too
whole
much.
body thing. It
It's
kind of
too
just
much.
looks like a real video.
It's too much.
But like
It's too
they
much.
just have like UI and that shit.
We've gone too far. Gone too
Yeah,
far.
I was joking. Like we're watching. What's it called? Have you guys heard of the short Narcos?
Yes, I love Narcos.
Yes.
Which one? There's like 3 of them, right?
Yeah, I mean, I'm still watching season 1, so no spoilers, please.
Okay.
But yeah, like in season 1, there's like one scene where there's like I'm not gonna give too much detail in case there's any spoilers, but there's like one scene where there's like a bunch of cops like raiding like a house, and they're like kind of grouped up, and then they like the guy inside just shoots like an RPG and gets like a whole bunch of them.
Damn, dude.
And then I was like, you know what? I was telling my girlfriend, I was like, you know what? Like, this wouldn't happen right now because people will just play too many video games. They know not to group up. They're gonna be like already in place and everything.
Don't get
like,
squad wiped.
Yeah, I was like, maybe the kids might be too soft. They can't take a bullet and walk it off. But trust
Yeah.
me, they're gonna get shot significantly less.
Yeah, they know the tactics.
Yeah, I was like, we played too many guys. When I was watching it, I was like, why is everyone grouped up?
Yeah, dude, this
Why
is
no one
bad
in
squad play.
position?
You're taught to group up. You're taught power in numbers. It's
but-
stupid.
Splash damage is real.
Yeah, but for police raids, they don't exactly expect somebody to, be carrying a fucking RPG.
That's true. That's true. We do have laws in the U.S. preventing that, I guess. I mean, you can't. We're making it difficult to buy one. Hopefully,
Yeah,
The problem with RPGs is that you can
difficult
technically make
is probably problem.
the ammo yourself.
Yeah. Ramton,
Just get a
what's up?
fuck ton of fertilizer.
Stop. Ramton, what's up?
I was saying the word difficult is already itself problematic, not impossible. You're
Not
like,
impossible.
Under certain conditions, you can still get an RPG. I'm like, I can't think of a situation where you need an RPG for.
It's like,
On
yo,
the
I'm
fence,
going
bro.
deer hunting. I'm going deer hunting, but I need to hunt a lot of deer, and I just want
Yeah.
nothing to be left of it.
That's,
listen, bro.
that's a waste of
Trust
money.
me. What happens if you get in a home invasion situation, but there's multiple of them?
Yeah, but you destroy your home on
Conserve
the way,
ammo,
dude.
bro.
You destroy
Conserve
your
ammo.
home. That's not good.
I don't think you want to use.
Okay, that's collateral damage, alright?
Oh my god.
Don't
Worry
Initial
about that
dog.
later.
Initial. All
I
right.
love using.
What's up? We got Miffy here. We got some new people. What's up, guys? Welcome. Here, let me introduce. We'll get kicked off. We've been here for 10 minutes. Welcome everyone to the Golden Hour AMA podcast. My name is Dr. Gold. I'm joined by Ramton. We're here to answer any sort of like math, science, life, social, whatever. If you're new to our Discord here, what we do is we have a stream 3 times a week where we do free math and science like tutoring and whatnot. You can kind of see that. This is an example of what we were doing yesterday during our office hour stream. We were solving something about semicircles and whatnot. So if you guys need specific math and science homework questions, that's a great stream to go to. And you can always figure out when it is by doing exclamation point schedule in the chat. OU Mark says, did OP Black get coin? Yes, he did, OU Mark. Anyways, this stream we created is kind of more laid back for, going over any more broad like questions you may have about whether it be math, science, anything going on in your life. Like, I don't care if it's, you're trying to pick out balloons for your mother or something, or, dating advice. We'll try to answer things as best as we can. You guys out. Miffy says, can you guys do chemistry? Yes. We do a lot of chemistry. I teach a lot of chemistry. Actually, I was just teaching chemistry an hour ago. I was doing titrations. What One of the acid bases are like one of the core things in chemistry, and I was just teaching Tai Chi. So yeah, Miffy, if you have any like chemistry questions, so here, Miffy, there's a whole channel called here, help screenshots. I'm gonna tag you in it, Miffy. If you post a screenshot of whatever homework question you have, then we can go over that during the office hour stream is what I do. And so the next one for that will be tomorrow. Today's more, we can do homework questions, but I kind of want to reserve this hour for just kind of more open-ended, you know, off the topic, like not like super, you know, what's the atomic number of this type question. But tomorrow, great time. Just post a screenshot of what your homework question is. If you can't make it to one of the streams, I will occasionally, like, if I have time, I'll write up a solution for you. Ramton's done this too. He'll write up solutions for certain questions, and then we can just send it to you. Yeah, good, Miffy.
Yes.
How'd you find us, Miffy? Oh, this is always cool. I can check now. Invited by TikTok. Oh, you found us through TikTok. That's super cool. Yeah. I put out a TikTok video on projectile motion, and it's been getting a lot of views. Just, I guess, been driving traffic to our Discord and whatnot, which is cool. I gotta put more stuff out. I'm having a super hard time in chem.
That's dope.
Well, that's not dope. Sorry.
That's dope.
Nope. God damn it, wrong one. There we go. That's the right soundboard. Sorry, Miffy. Yeah. I'm sorry you're having a hard time in chem. Let us help you. We do. I help a ton out in chemistry. If you have, so a great way, Miffy, to get help is take a screenshot of like a homework question or a quiz question that is difficult for you, and then come by on the stream tomorrow, and I'll go through it and I'll teach it to you, and I guarantee it'll make more sense to you. Slimy, can you stop calling people gay in the stream, please? God damn it. What time is my stream tomorrow? Here. So anytime, if you want to know, that's our regular office hour stream schedule. So Monday, Wednesday, Friday. As you can tell, we also have, like, you know, a bunch of prepubescent 13-year-old kids who are calling each other gay. I don't understand. Why do you guys like single out each other's sexual preferences? Like, chill guys, you know? Bro. Yeah, cap. It's okay. This is a Discord for everyone. I don't kick people unless you're being super toxic or racist. Please don't be racist. I mean, I'll give you warnings, but, you know. OP Black, chill. Can you y'all chill, please? Jesus. Chill, please. Bro, racist. Okay. Let's see. I think Ramton. Yeah. Ramton, say what you want to say, Ramton.
No, I was saying I saw some cool questions posted.
Yes. So we have yes, the black hole space-time fabric. This is cool. Here, Ramton, you want to explain this one? I like this question. This is a good one. Yeah, Teacup, let's do your question first. I like this one. How do black holes affect the space-time fabric of the universe, and what are the implications of this for our understanding of physics? This is a very high-level question. Jesus, Teacup, good job. I like it.
Yeah, this is a pretty, like, it could be pretty in-depth question, like, depending on, like, your level of understanding.
I think his understanding is like let's say like 7th, 8th, 9th grade level.
Okay,
Physics.
yeah. So I guess, I mean, there's not necessarily a need for
if you want to draw anything, you can. I'll leave it up here if you want to draw stuff, you know. Or I can draw stuff. I can animate. We can do one of those. What's it called? Kurzgesagt, where the guys like they teach like a science subject and they have these really cool animations with it.
True.
It's pretty cool.
Yeah, like okay, so I'm gonna explain how, like, essentially black holes are to a certain degree.
Sure.
Without getting into too much detail. But, like, Teacup, if you want to clarify about what you mean also, like, how does this affect our understanding of physics as well? It would be like, you know, because there is a lot of implications, actually, right?
Yeah.
To what
it's
extent are we
far-reaching.
talking?
It's wide as the universe.
Yeah, exactly. So like, we think of, like, typically, if you want to think of, like, space, we think of it as, like, you know, like a sheet for now, right?
Mm-hmm.
Although it's 3D, we kind of like to, because we can't imagine four-dimensional things into three-dimensional things into 4 dimensions, then we remove like one layer from it, so we can start to think of like three-dimensional things in two dimensions, right? Because then it's going to be a little bit easier to
It's like
understand.
taking
So,
it's like taking a like you know a 3D object and taking a picture of it, right? That's a 2D representation of something that's really three
Exactly.
dimensions.
exactly. So, if like this space is like a sheet, if you can actually kind of, this is an analogy that to a certain degree breaks down, but it's a pretty good way of like introducing, something still like on the elementary level, right? So, I mean, to a certain degree, it works pretty well. So, if you have an object that sits on this sheet, you can think of this as like some kind of like a bed sheet, right? It creates some kind of like a dip inside of that sheet. And so, if this sheet was stretched out and you put like a heavy object inside of this, then this object creates some kind of like a dent inside where it's a curvature. So let's say this is a big object. It's like let's say heavy basketball or heavy bowling ball. Like that's a better one. Put a bowling ball in here, and then you want to roll a marble. Like previously, if you were to roll a marble on this where the bowling ball didn't exist, it would kind of like roll straight, right? But now that there's some kind of a dent. As it gets closer to that dent, it starts to kind of like fall within that dent. And then we'll kind of go around, or maybe depending on how close it is, maybe we'll go around and then kind of go off, or maybe if it's closer, it would like go inside, and then it would like stick to that thing. So this is actually kind of like a good analogy of how things get affected by gravity. Now, for a black hole, it looks like kind of like an infinite dip in the space.
Yeah, it's like
So
it's like
if
oh no.
something falls into this, it's actually just gonna kind of, you can think of it as like it's gonna roll down, and this thing kind of keeps going. There's no like point end to this. And then at the center of this, there's a point that goes infinitely low. And that point is what we call singularity.
Yeah, so you guys have probably seen the word singularity before.
Yeah, so that's the definition of it. And then there is a boundary to this. Like that's what I've drawn in there. That boundary, if something enters this, if something like is passing by, what's it called? Passing by around this, if it has like enough velocity, let's say, it can like kind of escape this. Sometimes it happens like this. It can kind of go around and then go the other way. But if by some, reason, it ended up actually entering this boundary, regardless of however its speed is, it will never be able to get out. So it will kind of like spiral down, and it will kind of
Like,
just
oh, no.
go down. Yeah. And so that boundary that the thing goes inside and is not able to come out, this is what we call an event horizon.
Yeah.
So this is what we call the event horizon.
This kind of comes into play. Like you guys know what the horizon is. On Earth, if you see the horizon, if you look out, it's kind of where the sky right meets the ground. That's what we call the horizon. It's the same with like a black hole. It's the point where light can't escape anymore, so you can't see anything past it. Everything is just gone at that point.
Yeah, exactly. Which is as you said, light can't escape. So as I said, because nothing can escape it, not even light can escape it.
Yeah.
That means that the gravity inside of this event horizon is so strong that even it pulls in light particles inside of this. Now, light actually does get affected by gravity as well. So depending on, if you have massive objects, typically turn out to be like really big stars or dense stars as well. Or black holes are probably the best examples.
Black holes are the densest thing ever, right?
Yeah,
in the terms of like I guess gravitational pull, right?
Yeah. The black holes,
they don't have mass. Black holes don't have like a mass per se, right? But they act almost as if they do.
Well, I mean, depends on how you want to measure mass, but they do have masses.
Oh, okay.
Yeah. So they do have mass. So the ratio of their mass is actually depends on their size as well. Yeah, so when, as you said, like these are so massive and dense that when the light enters them, it's not able to escape.
Mhm.
So every light that you would see ever coming from around the black hole, so like I don't know if people have watched like Interstellar. Those are the
Yeah,
lights that are
the
going
Tesseract.
around the black hole. Sorry?
Isn't he stuck in a tesseract in Interstellar or something?
Yeah, at the end, yeah, exactly. Yeah, but so, um, when when you're watching like any sort of light or any light that you're observing, it's coming from around the black hole. So it's kind of something like this happening. It's like goes around, and then it like comes back and sees. And so like as you can see, like I'm drawing extremes with this. So there
Mhm.
could be some lights that come like here, and you reach your eye, but there could be some lights that are actually going from here and it turns around. So you could actually look to the side of the black hole and see yourself
It's like a
because the
mirror,
light,
black hole mirror.
yeah, to a certain, yeah. The only thing is like it kind of scrambles it, but like let's say if you had like one single particle that you could like distinguish and everything, you'll be able to kind of like see yourself on if you're standing in front.
That's
If
cool.
you could be also at the very extremes of this, there could be lights that are going in like a perfect circle. Those are the lights that are exactly on the event horizon.
Uh
So if you're like sitting at the event horizon, you would be able to see the back of your head by just looking forward.
huh. Oh, that'd be
So
super
that
weird.
yeah. So like I think this is kind of to a certain degree like when we say how does this affect us like to a if you are at like a decently distance away, and when I say decently, it kind of depends on like whatever the size of the thing is, the size of the black hole is. But if you are decently away, you can treat the black hole as if it's like a mass with like a mass of a star, or like a star with a certain mass away
Mhm.
from you. So the
Mhm.
physics doesn't really change much. It's when you start to get closer to the black hole where you start to see some effects like time dilation, and the gravity gets like significantly stronger as opposed to you being close to a um
Now, is that why time dilation becomes more of an effect because the gravitational pull of the black hole makes you closer to the speed of light? Kind of. What do you think?
uh
Like,
so
why is time dilation happening? Besides I guess I understand the space time, like you're just
from like
sinking
an
the blanket.
intuitive standpoint,
Yeah.
um so one thing that I could think of like an example of like thinking about this is that um let me see how I can try to explain the time dilation, because for special relativity is actually really easy to explain
Mm-hmm.
because you actually need like, as I said, less than high school, like pretty much grade 9 or 8 level math to actually understand special relativity.
Right.
But for general relativity, well, here's the thing. So when you get close to you have to actually think about how light gets affected. So if you had typically the lights that we have are going to be measured by atomic clocks,
Yeah.
right? So it's like the bounces of like you have like two plates and you have like a light that like goes up and down and bounces off between
And
these
we
two
know the
plates.
frequency that happens, and then that helps us like tick tick tick.
Yeah, exactly. So you measure the time based on the frequency or the number of bounces. So when you
Okay.
have when you're close to the gravity, this will actually start to drain energy from this like light,
Oh.
because it's like slowing it down, it's like pulling it,
Okay.
right? So you can start to think like if it was to go um one way, it would like lose its energy, and the other way it would kind of like gain as well, but you can like do the math to realize that there is a difference between like the bounces.
Sure.
And so it would actually be like the time it would normally take, it would be different compared to if there was no gravity, right? So it would take longer
Mhm.
compared to if you are outside. So if you are on the near the black hole, you would actually experience time like normally because everything is slowed, kind of, you can say, relatively, hence the word relativity as well. That relatively the
Relative.
same for you. So you experience everything the same, and
Yeah.
that's what there is in Interstellar as well.
Yeah.
Where he's experiencing time normally, right? But the reality is like time is
Around him, right?
passing-
Things are going past like
passing by
faster.
significantly slower.
Hmm.
Yeah, exactly. So then you would end up with like in a time frame where time is significantly slower for you, but the outside world is passing. The time is passing by much faster.
Right.
So then you would the outside world ends up like aging kind of faster,
Hmm.
right? So that's why he became like he was younger than his daughter at the end of the movie because the daughter was like not near the black hole. So time passed by like years and years, but he was like on the near black hole for like an hour or something.
This gets into the whole thing of like we should do a separate stream on this at some point because it's still like I have to refresh my memory on it. The twins paradox, you know?
Yeah, so the twins paradox is a pretty cool one. Like it's a paradox until you kind of understand exactly what's going
Yeah.
on. And it's no longer a paradox.
Right.
But if you want to, I could explain it now, or like we could do it for another time as well. Just so
Yeah,
we can-
let's yeah, I want to maybe let's think. Yeah, because I like this. This was a cool question. So Teacup, this is a very cool question. I like this one.
Yeah.
Was dope. What's up?
W question.
W question, dude. Yeah, this is very cool. I'd like learning about this and black holes and whatnot. I want to maybe do like a dedicated day for us to do like time dilation and then the twins paradox because I think that would be a cool
Yeah.
thing. But that's gonna take like a half hour at least.
Yeah, exactly.
Yeah. So we have a queue of things we can go through. Well, let's see. Let's see what other questions we have from people in
Yeah, we can come back to it.
Yeah, we can always come
But
back to it.
I hope it answered what you were hoping
Let me
to.
make sure I put mine in the right spot.
Yeah, I'll check.
It did, in fact, answer the question. Good explanation.
That's awesome, dude. We like that. Wait, where's my? Yeah, there we go. All right, let's see. Okay. Initial did ask a question. He said, oh, yeah, you put it. There you go. Can you teach about
there you go.
thrust vectoring in an aircraft? What does it have to do with physics? Oh, this is pretty cool. I like this actually. Yeah. So we talk about thrust vectoring. You're probably talking about what was the first airplane to have? Was it F-22? The F-22 was the first to have
No,
thrust vectoring?
far from F-22.
Really?
Su-27 or MiG-29?
Oh, the Sukhoi? Yeah, yeah. Those are was it
The Russians invented it in the first place.
Did they? Who invented,
Yeah.
who invented
They've
thrust
been
vectoring?
putting it on almost all their aircraft.
That's
Kind of
pretty
their
cool.
thing is that everything goes spinny.
Well, apparently Robert Goddard did. But yes, you're right. Now, thrust vectoring has been around for a while in terms of rockets and whatnot. Does the F-35 have it?
No,
Doesn't.
you
But
can't have it on a VTOL.
What's
but no-
thrust vectoring?
Yeah. Okay. So that's this is a cool thing. So thrust vectoring
that
is
like
it's
mass
just moving.
propulsion?
It's just moving the rocket engine right in the 3 dimensions. I guess is what. Or really
Well, I
just
mean,
two.
it has multiple dimensions. I'm pretty sure it goes from 2D to like 8D.
8D? No. There's no such thing as 8D.
Yeah, I'm pretty sure there's 8D.
Thrust vectoring 8.
Just
What are
search up 8D thrust vector.
I am gonna look that up. I don't. What are the other dimensions? Like what? Pitch, yaw, roll, or something, dude? What? It comes. Maybe it's 8 axis or something. But yeah, thrust vectoring comes to being able to like move. So here, this is actually a good idea. Here, let me go over this real quick. Because this is how, for instance, traditional aircraft work, right? So traditional basic aircraft have here. Let's make this my plane. I know it's not gonna be the prettiest plane, but whatever. Okay. Traditional aircraft
It's fun.
just have some sort of engine, right? Let's say this is like an engine here, okay?
Yeah.
And then this provides thrust, okay? Thrust can be thought of as like a force. And it's actually very cool because what's happening is the air all around us is basically a giant fluid, Okay, you know if you're in a pool, right? If you like move your hands against the water to like push away, that you move, right? And then relative to the water, it's the same thing with engines in the air. What they're doing is, you know, they're pushing against this fluid air, and that causes the plane to move forward. And you know they can do this with a bunch of different things, such as like a turboprop, a turbine or whatnot. It's basically just taking air and then pushing it out the back. And if you push air out the back, you move to the forward by what's called like conservation of momentum. Actually, this is another cool concept. So yeah, a traditional plane works by pushing air backwards, okay, just straight, and then using ailerons and what's the other one called?
Ailerons, fuck.
Yeah, I know,
Flaps.
right? Flaps and
Technically.
ailerons. Yes. So they use, for instance, you know, they're almost like rudders, like on a ship, right?
And rudders are on there. Rudders
Yeah,
are on the tail,
rudders
but
are
they're
a
only
thing.
for ground use.
Right.
You
Yeah.
don't use them in the sky because all you do is just start spinning
Yeah.
back and forth.
Yeah. That's a whole other probably dynamics question. But yeah. So what a traditional aircraft does is it just like pushes some force straight back, and then uses these different flaps and rudders and whatnot to navigate through the giant ocean of the sky that we call air. You know, that's the fluid. This is cool, but there are some limits, right, to like how tight of a turn you can take and whatnot, because you have different stresses on the ailerons and the flaps and whatnot, that you try to take things, if you try to do too tight of a turn, you'll end up just like snapping it. Like mechanically, like you can't have that much force against it. So what they invented to have increased like cool maneuverability is it's called thrust vectoring. So now instead of the engine just pointing straight back, the engine can now rotate and like kind of spin on like different axes, and this allows you to not only, you know, move the plane with your flaps and rudders and whatnot, but to also like basically change it, like, oh, I want the engine to fire this way, so now the plane will move in the other direction. I think there's some cool videos on this actually. I've seen some. One sec. YouTube thrust vectoring. I think it's on the F-22 is the US one. Yeah.
There's way too many.
And maybe they won't actually show us like what it is because it's probably classified or
It's
something.
on the F-22. It's on a few experimentals. It's on a few NASA's.
Yeah. Oh, well, they're not actually... I want to see, like, the demonstration of the... I'm trying to think. What is... Let's see. The other big thing that this works on is on SpaceX, for instance. Their rockets and whatnot.
Yep.
So here, SpaceX, thrust vectoring, which is very cool.
Yeah, I think I've heard of the name. I don't know if the thrust vector, but there's propulsion engines that they pretty much shoot like masses at like a really high speed.
Yeah. Where is it? I want someone to show like, no, this is a toy rocket. Man, dude, why? I know the video I want. It's super cool. It shows how the rocket engines and like the jet engines work. Thrust vectoring jet. Maybe this will show it. I want to see it. Here we go. There you go. Someone's gotta love YouTube. Someone's always got something on YouTube. Where's the video? I want the cool. There's a cool video of actually watching how the jets move. Pretty cool. Girl.
I'm not gonna lie to you, bro. Legit, just watched this video.
Did
No.
you?
Legit,
They have. It's funny. He puts it on the fucking thumbnail, but he doesn't actually show the video in there. But do you see how the jet engines are pointing in two different directions here?
Yeah.
Yeah, that's what thrust vectoring is. They can basically move the engines which way they're pointing. Which okay, here we go. This is cool. This is a good video. So yeah, these are the see how the engines like literally move in different directions. So you not only have the flaps here in the back, which gives you cool maneuverability, you can also move the engines, and that gives you the ultimate amount of just handling in the air, I guess. And this is cool. I'm trying to think like how there's these look really cool to me. How they kind of like rotate to move and whatnot. There's like an engineering thing for that. I'm trying to think how that works. Someone made a handmade. Dude, these people just making jet engines in their backyard. Jesus, what? But this is cool. Yeah. This is an example of he's not changing the direction per se, but he's changing the amount that the nozzle opens and closes. So that provides different stuff as well. Yeah. This is a little toy.
While we're sitting here nerding out, you want to look at the I think it is turbojet to ramjet. Or turbojet versus ramjet.
Ramjets are very, very, or for high speed, right? Like
hypersonic.
Hypersonic, yeah. A ramjet is it's actually in all the news these days because the Chinese apparently have like ramjet missiles and we don't or something.
Okay, so it's an anti-carrier missile, but the problem is the Chinese are so bad at it can't hit a target.
It just goes very fast.
Trying to make that little minute change in direction, carriers don't stop moving. They never stop moving. They're about as fast as a speedboat, your normal speedboat. So trying to make that little like minute adjustment with something already going Mach 7 or faster is near impossible.
Well, this one apparently goes Mach 14. It's a scramjet or something. Yeah, this is cool.
Oh, yeah. Scramjet. That's the transition one.
Yeah, this is cool. Yeah, ramjets can go apparently between Mach 3 and Mach 6. What's up, Ethan? Good to see you. Scramjets can go even faster. Like, wow, that's cool. Mach 12, 14. The funny thing is, like, the U.S. government won't even tell us sometimes what the actual speed is.
They can definitely go faster.
That's crazy, man. It's so fast.
If we figure out the right fuel combination and everything, it could probably get up to 20. But that's probably the absolute maximum.
One second.
And that's like getting towards like if we figured out how to launch like ICBMs into space and then use it like that, you know.
So
we'd have to get to that level for it.
This is also very cool. This is an example of thrust. This is thrust propulsion, I guess, or propulsion vectoring. This is what Ramton was talking about. So SpaceX has these rockets which are very cool that they're reusable. Usually when we send rockets up to space, we don't care about them coming down. We just let them crash in the ocean and we're done. These rockets that SpaceX has developed are able to come back down and be reused. And the way they're able to do that is they have, do you see how this, you can see how the rocket, like the jet moves. It's super cool. It is honestly like, sometimes it doesn't land correctly. And then it just explodes. Yeah. I remember there's a bunch of these that they've tested and whatnot, but it's beautiful. It looks like you're running like a rocket in reverse. But yeah, that's very cool. I think look at this. It comes down at like an angle, and then it starts moving a little bit, and it's like, okay, cool, nice landing. Wow, good job, rocket. Yeah. I have some buddies that work at SpaceX. Actually, I should maybe try to get one of them on the podcast here at some point. Just talk about their stuff. That's cool.
Also, some nice questions. Also, people.
Let's do it. Let's do
Yeah.
it. What else? What else did? You know how many people use Golden Hour? I don't know if that's a question. What? A lot.
Where are these questions coming from?
Let's see. Okay, let's do the next one. How can astronomers know things for certain since they only look at space from one vantage point? I like that.
Yeah. This is
What do you think about that?
I wanted Riplaw to clarify what he means because there isn't really the answer could be really cool. I'm not sure what he means by.
Maybe let's pretend his question is something so that the answer is very cool.
Yeah. So. Like, I guess one thing you can. So I think we talked about the expansion of the universe a little bit.
We did.
So and I think the question is like what he means know things for certain. So let's say you're looking deep into space, because the universe is expanding and things are getting further from you. then the further you look into space, you are looking at things that are coming from a further distance, and they're also getting away from you essentially at a certain velocity. So what happens is, like, first of all, you're looking towards the past.
Yeah.
So that's one thing that happens. So the reason whenever we say, I don't know if everyone's probably heard the terms like, light year, or like, like 10,000 light years.
Yeah, Buzz
Right.
Lightyear or something, right? Yeah.
So 10,000 like light years is essentially the amount of time people think that this is a unit of
Is it not a unit of distance? Is light years is
Yeah,
a
it
unit of
is, it
distance,
is.
right? Yeah.
You're right. Yeah, people think this is a unit of time, but it's not. It's a unit of distance, which
Mhm.
means that it's the distance that light takes to travel 10,000 years. So,
Right.
like, technically, you're getting both the time and the distance at the
Yeah.
time. Like, the light year is equals to, one, or like it would be 365 days times 24 hours times 60 minutes times 60
Seconds.
seconds. So this is the time, and then you multiply this by the speed of light, which is 3 times 10 to the 8 meters per
Hmm.
second, and that's the distance. So
Right.
if something is coming from 10,000 light years away, it's taken 10,000 years to reach to us. So we're looking at the past,
Because
essentially.
that's the fastest that like information can travel, right? Speed of light.
Exactly. And then light is like a wave. So it kind of looks like this, right? So let's say if the thing is getting away from you, and the object is, moving away because the universe is expanding,
Mm-hmm.
this light is traveling in an expanding universe. So what happens if the universe expands? Well, it's still moving towards us, but what happens is because the space itself is expanding, this ends up like getting stretched out. So it starts to kind of look like this. So instead of you getting like, a certain frequency, or the better way of saying it is wavelength, the wavelength gets stretched. And so if you were to, let's say you're seeing a color that was supposed to be green originally, right? It would become red later. So you're actually seeing something that has become stretched out. Now the speed of the light actually doesn't get affected, and that's the thing that is a little bit, could be counterintuitive. Is that the light that you see, although the space is getting stretched, the speed of the light stays the same, being c. But if the space is getting stretched, then what about light gets affected? The wavelength. So
Mhm.
the wavelength goes down, and this means, the wavelength goes up because it's stretched, and the color gets closer, like, from, let's say, green to red. So this is called what we call a redshift as well. So that's where the name comes from. So a redshift is when the light gets stretched, and then if the light gets squished, it becomes a blue shift. Yeah, exactly.
Yeah,
And
isn't that the whole? There's that whole joke of like the cops, like, do you know how fast you're going back there? Or no, it's the bumper sticker. Have you seen the bumper sticker before?
I think I know, but I've forgotten what it's.
I'm finding what it is. It's the Redshift bumper sticker. If this sticker is blue, then you are driving too fast.
Yeah.
Physics jokes.
That's a cool. Which means that if you're going too fast, the light that is supposed to come from it is becoming squished.
Yep.
And so because of that, it becomes closer to the blue color. That's what they call it, blue shift. But yeah, that's a. So how do the astronauts know they're looking at things for certain? Well, technically, you don't know. You're looking at the past.
This is honestly why I could never get into astronomy. First of all, I had a terrible astronomy teacher in undergrad, and it turned me off to astronomy like forever. But one of my big problems was, you know, they would talk about, oh, well, this light blinks like 4 times a second, which means it must be a pulsar, so it must be rotating. It must be. I'm like, we have no clue what's happening out there. Like and even the things we're seeing, we're not even sure if they exist anymore. Like,
Yeah, exactly. So there's a lot of like
boggles me.
guessing things, and it's because like you can think of like an ant trying to figure out like the map of the Earth,
Yeah.
right? Maybe even worse, to be honest. Like the size of an ant relative to Earth is probably way smaller or way bigger than the size of us to the universe. So you're trying to map things or understand things at like very large distances that you can barely see. You don't know their distances. You don't know their
You assume the laws of physics are the same out there, right? That's the fundamental thing we always talk about too,
Oh
right?
yeah, so that's one thing as well. Like you assume the laws of physics are the same out there.
Right.
So
Maybe they are.
Um,
I don't know.
yeah.
We
So
hope they are. I think that's the
basically-
fundamental assumption, right? Is that they are.
I think we are pretty certain that the laws of physics are the same, like pretty much the same way. So we haven't seen anything that goes against it. I think the biggest thing is like we have to make the observation like really accurately and all this stuff.
What was that tablet thing that we sent out? It was in gold. We put it on like a spaceship and we sent it. Do you know what I'm talking about? Was it Carl Sagan that did it?
I'm not sure.
One sec. Spaceship,
What was it called?
gold, tablet, satellite. I don't know. It's where is it? No. Satellite. Oh, the Carl Sagan message on Voyager. Voyager, that was it. It was yes. We sent something, and it's the furthest. We sent it out in like the 60s or 70s, and it's the furthest thing away from the Earth right now. And okay, here it is. And this is what we put on it. We put this image. Pioneer 10. One second.
Aliens see it.
Yeah, so if aliens see it, they can figure out who we are, and it's very cool to see what we tried to tell them. So here, this is actually very cool. People probably don't know this. Yeah, it's called the Pioneer plaque. Yeah, this thing's pretty cool. So yeah, we put this in all gold on a satellite. We shot it out, God knows how many years ago. I think 40, 50 years ago, and it's the furthest thing away right now. And yeah, someone did all the explanations of like what all the different things are here.
I think it's supposed to be like the shape of our bodies, the lens that we are.
I think
looking
also
at,
it's the hyperfine structure of hydrogen. That's what it is.
Yeah, something like that, so that we know about like the
Yeah.
molecules are made or things are made out of
Yeah,
smaller molecules.
I think this is supposed to be like hydrogen, right? This is like, hello, these are what we look like, So, and then I think these are the planets. Oh, and they're showing, okay, right? This is the sun. We are the Earth. And then I forget what this coding is. Do you see how there's a bunch of like lines and then dashes and whatnot?
Yeah, I don't remember.
It's very yeah. What my buddy has this tattooed on his back. One of my physics grad friends has a massive thing of this tattooed on his back, and I was like, what? Yeah. Oh,
That's
man.
a good one.
Right? It's always cool to see when people got cool physics tattoos. I don't have any tattoos. Do you have any tattoos, Ramton? You have any?
No, but if I were to get one, I would either get like a physics one. It would either be the Maxwell's equations.
Okay, Maxwell's are cool.
It would be the Einstein's field equation or the Dirac equation. I would say those are probably because those are the all fundamental like equations that explain
basically all of life so far.
Yeah.
Right. Yeah. No, man. There was let me see. They probably have on the wiki article like what's on it. Yeah, it was giant gold. Right. This is the hyperfine figures of man and woman, relative and and 14 pulsars with their periods denoted is what it is.
Ooh, I don't know.
Showing redundancy so that the location of the origin can be triangulated, even if. Okay, but what do the dashes mean?
Oh, I see. That's pretty cool.
Oh, it's the period of the pulsars. Oh, okay. And they do it in binary.
It's in binary, yeah.
Uh-huh.
The binary is universal to us pretty
We
much.
hope the aliens understand ones and zeros, right? You
The
know.
binary is universal because the spin is binary. So if they've
Right.
discovered
Yes. Either up
it was
1/2 or
spin-
minus 1/2. Yes. Oh, that's so cool.
Yeah. So that's why binary is like universal because like every other thing is arbitrary,
Hmm.
but the spin being up or down for electron because that's universal to the laws of nature, then binary would make sense to them.
Hmm.
But anything else like hexadecimal is like obviously
That's just computers,
arbitrary.
right? That's like 2 to the 5th or something.
easier.
Yeah.
And then the 10 because I'm pretty sure we chose it because we have 10 fingers. So it's
Yeah.
also
Is that? Yeah. You think that's why we came up with 10? It's interesting how other countries count, right? You know, I think Chinese has like one of the most intuitive ways of counting or something. Like English is apparently one of the dumbest ways to count, I think.
Wait, what do you mean? Like
I just remember someone saying it. It's like the Chinese language with counting and whatnot is very different than English, and I think it affects like how they do math. Like they're able to they process it differently. The Chinese number counting system. I don't know. There's
like what is this special about?
yeah. Oh, I don't want Chinese counting math English
What's
difference.
special about these?
I know there's something here.
Like is there a certain way you count?
Oh, here it is. Okay. Yeah. Well, they talk about this linguistically, right? So to count from to 1 to 100 in English, you need to know 28 different words. But in order to count from 1 to 100 in Chinese, you only need to know 11.
Oh,
Like-
past China goes 10, 1, 10, 2, 10, 3.
Oh, okay.
Right.
Oh, how do you say like 41? Oh, yeah. So for like 40 something, like 42
Uh-huh.
in Chinese is apparently 4-10-1 or like
Yes.
4-10.
Yeah. So they do math like already in their like counting system,
Yeah. Okay.
which so kids already learn like the multiplication tables and stuff.
Yeah,
It-
that's true. Yeah.
It's super cool. Yeah. So
Is that both Mando and Kanto? Okay. Yeah.
yeah, and then okay, I didn't know this. The thing on the right, that's a depiction of what the satellite looks like, and then the relative size to humans. So they're kind of saying like, hey, we are
Oh,
this
yeah,
small.
yeah.
So
What's the rectangle then?
I believe that's part of the satellite. Then it must be.
Oh, okay.
I think it's part of the satellite. Aircraft. Yeah. Yeah, this is a silhouette of the spacecraft, I think. Yeah.
Oh, okay.
I guess there was a big rectangle on Pioneer 10 or something. How far is
Yeah.
Pioneer 10 out at right now? That's a good question. I don't know if it's definitely not transmitting anything more, right? It was sent off 30 years ago. That's so cool. Last contact was 2002, and it's approximately 82,000 miles away from the Earth right now. So we got, we've sent out the longest DM ever, to aliens. I don't know if we want the aliens to find it though, right? Now they know how big to make their lasers. They're like, oh well, they're only this big.
I feel
Anyways,
like if
Go on,
aliens
Remsen.
were to be, I don't know if the one of the biggest questions is like whether aliens would be hostile or not. Because
yeah.
the only reason for them to be hostile is to take over our planet. But
If
we've
they
already
want our
fucked them up.
resources, right? Or if they perceive us to be a threat.
Yeah, so I mean, if they are perceive us to be a threat, then that means that they are at the same stage, kind of, or they're more primitive, which means
Yeah.
they're not gonna find us.
Yeah.
So most likely they are more advanced, and we've already messed up the planet. So
Yeah, so they're like, oh, yo, these guys
are.
already screwed up.
Yeah, I don't think they're.
We don't
like,
want that.
unless there's somehow they can restore planet because
Oh.
of regenerative properties, which means that why are they not doing it on their?
Yeah, I love the whole theory of that. Like, if you watch Rick and Morty, of course, right?
Yeah.
Where we're just like the battery for like another alien car or something, and they're just
Oh
watching us. They're just watching us. It's like peace amongst worlds, Rick.
We're messing up that car.
We are definitely messing up that car. It's not good. I think it's cool when they talk about like humans as being like an experiment. Or, man, what is that? What is that one book where like it has to do with the whole singularity thing and whatnot. Where we keep asking the machine a question: what's the purpose of life? And then eventually, like, you know, the world is created. Man, oh man,
Oh yeah, I don't remember exactly.
you know, I know this book. One second. It's actually a pretty good book. It's what is the meaning of life? Asks computer. Not the 42 one. I know that. That's from what was it? Hitchhikers. Singularity. Yeah, something like this.
Well, Habib is in the
Hopefully
Isn't
they
it
don't throw
checkmate?
out the broken battery. Yeah, don't throw it out.
That's dope.
Don't do it. Don't do it.
yeah, but it's like what's it called, riddle, and I've been thinking about it, driving me nuts.
What riddle is it?
Like, read it in the submit your questions. It says, "You measure my life in hours, and I serve you by expiring. I'm
Oh,
quick
okay.
when I'm thin and slow when I'm fat. The wind is my enemy. What am I?"
I'm
This
quick.
is a-
When
I can't. Do you have the answer?
I serve you by expiring, dude. What is that, Habib, dude? I like that, dude.
I've been thinking about it for a few hours. I can only find things like, I don't know, when you measure my life in hours and I serve you by expiring, I'm quick when I'm thin and slow when I'm fat. The only thing I thought about was like milk, but I was like, it doesn't seem like it's gonna be the right answer because like it has nothing to do with wind. So he says, "Get me on stage."
All right, I'll get him. Yeah, put him on stage.
I want to try and figure it out. Where is it?
It's here. It's he put it here. One second. I'll post the text. Put it in here. There. It's in the Twitch. It's in the Twitch chat. Post it in the chat too.
Could it be?
Yes, Habib, come up and speak.
Alright, hello.
What's up, Habib, dude?
Is it a candle?
Serve you by expiring.
Is it a candle?
The
How did
candle,
you know?
I serve you by expiring.
candle,
It is a
yeah,
candle, yeah.
candle.
It is a
Yeah.
candle. Did you look this up, Teacup?
No.
That's a good-
Yeah.
That's a good.
Because if you measure your life in an hour, it can only last a few hours, and it's got one of those weird 24-hour ones.
Uh-huh.
And when the wax, it melts down, so it gets thinner.
Yeah. It's okay.
The wind will blow out the flame.
That makes sense. I
Um,
don't understand the part that says I'm quick when I'm thin and slow when I'm fat.
Yeah, that one was weird. I
Alright,
don't get
okay,
it.
so you know how
No,
when
maybe
you-
because it
when you
expires
have-
faster because there's less wax on it, so it stops existing.
Yeah,
It's not-
like okay, so those like big like fat ones, I guess, like the ones with the bigger radius,
Mm-hmm.
they last longer than like a small thin
Oh
one.
yeah, makes sense because there's more wax to burn off. That's
Right.
true.
Or they
Yeah.
have like
Oh my God,
multiple
like-
wicks. You get like these triple wick
Like-
monsters.
I actually just guessed that
Yeah.
way.
Yeah, that's a
Good
fun
job.
one. I like that, dude. That's
Yeah,
kind of a
That's
cool
how I would
question.
guessed right away.
It
No,
took me
no,
a second to
it's good.
analyze it.
That's good.
I just guessed. I didn't think that was words.
All right, here. Let's spin it out. Let's do a giveaway for everyone who's been here in watching the stream. I appreciate it. We've had some cool questions. We've talked about some cool stuff. I've learned a lot about black holes. You know, we've had a good time. Let's see. What is it? It's the spinner wheel. Where's our spinner wheel? Spinner wheel. We love spinner wheel.
Just spin.
The spinner wheel. All right, here we go. This one is. Let's see. Who's in our? Who do we got? Okay, I got Initial. I got Habib. I got Riplaw. I got Teacup. We got Ethan. We got me. We got Bob. Who else is in the Twitch? If you're in the Twitch chat, what's up, English Lessons? Good to see you, dude. I love when English Lessons, dude. Raiding the party, dude. Yeah, we were just talking about black holes and all types of weird science stuff.
Dang,
We're doing
just put all the English people in the wheel.
yeah. If you're in the Twitch chat and you want to be entered, we're gonna give away like a $10 gift card to something. Just put your name in the
No.
Twitch chat. I'm gonna do it in the next like 20 seconds. Then we'll go on to some more questions. First raid. No, it's the second raid, Ethan. He did it. He did it last time as well. That's pretty cool. Never knew. Yeah, no, we appreciate it, dude. Okay, cool. I think that's everyone. I don't see anybody else that's saying stuff. Okay, let's run it. Bum bum bum. Spinny spin she goes. Who's gonna go to this time? Dang, dude. Teacup with another win, dude. You are the spinny wheel champion, dude.
What do you mean?
It's rigged.
No.
I swear this thing is not rigged. We put in random names all the time, dude. Here,
I'm just-
I'm gonna run it again just because I want to see. I'm just curious. If it says teacup again, then this thing is broken, dude. If it says teacup again, then I'm done, dude. Okay, see? Yeah, it would have been you initial.
It's
Would've been
not
you.
rigged.
It's not rigged. It's just okay. Congrats, teacup. Teacups wins another spinny.
W.
It must rate actual education.
Damn.
Oh yeah, that's awesome, dude. I like that English, dude. That's very cool, dude. I appreciate that. Let me know when you stream, honestly, dude. If you stream after this, like I'd happily, raid. I don't know if many of my people here need help with English yet, but some of them do, honestly. Like some of you guys' grammar is
Oh, me a
leave something to be desired.
Anyone's got cool or they'll have like interesting questions as well, feel free to put in the chat.
Yeah, in the Twitch chat. Yeah, if you have any sort of
Gold.
cool like math or science question or life question, anything. Actually, literally, you can ask whatever you want in this AMA. Just know that our our expertise is more science, math. Initial does know some cool history. Sick.
I can do basically anything on the tech side or military, just in general.
Cool. I like the
Gold.
military stuff's cool. What's up, Teacup?
Fuck my toe.
Je ne parle pas anglais.
Oh, je n'ai pas. Je suis Dr. Gold. No. Je m'appelle. Je
Stop
my name,
speaking
right?
baguette.
Hey, stop speaking baguette, dude. I'm terrible. All right, cool. I like that. It was a good one.
Yeah, we can do the next question. I like that one too.
Which one is it?
Be Black. It says, "What is anti-atoms or antimatter?"
Ooh, I like that. What are anti-atoms
No,
and
it did
antimatter?
dark matter. Now doing antimatter.
Yeah, that's a cool one. Yeah, let's do that, dude. I like that. Let's do that.
Wait. No, but oh wait, no, we're doing one more.
We're gonna do a couple questions. We're good. All right. You're good. All right. OP Blast, like, what is antimatter, or what do you say? Antimatter, anti-atoms?
Yeah, I don't know what anti-atoms are. I mean, actually, you could have anti-atoms.
Yeah.
Did you want to answer this, or
Let me do like an intro and then you can explain on it more. So yeah. So antimatter, right? In life, right? There are a lot of like dualities, right? There's like the positives and the negatives and whatnot. The same thing happens with matter. You can have matter, which is the exact opposite of matter. And what happens when antimatter and matter, for instance, collide with each other, they annihilate each other in this big like explosion that converts mass that they have into pure energy. That's what this is. This becomes like pure energy, which I believe this is what they call like rest mass energy. This is you guys have seen this equation, right? E equals mc squared, right? That's the amount of energy that is contained just in something having mass, like just in something having, matter to it. And if you put a matter particle next to an antimatter particle, they annihilate each other, and then it just releases a pure amount of energy, which is a huge number. Because you guys remember that, like, speed of light, c, that's 3 times 10 to the 8th. So if you're already squaring that, that's 9 times 10 to the 16th. Like, this is huge. I don't even know what prefix that is. Like peta something or past peta. But yeah, and so you've probably seen this in, I'm trying to think what movie this has been in that you guys have seen antimatter. Oh, I know what it is. It's
Cocaine Bear?
Does anyone watch Star Trek?
Yes.
I'm a Star Wars fan, but I'll take Star Trek
Oh yeah,
sometimes.
the new game comes out tomorrow.
The what, new Star Wars one?
Yeah, Jedi Survivor.
Where was it? Where was the Star Trek? I'm trying to think the thing with Spock. You remember how he has that like red thing or something?
The wedge like thing, and it goes boom. And then
Yeah, red. Well, like they put it into the plane. Here we go. Yes. Oh, they call it like red matter. What?
It's
Yeah.
the thing. It's like the maddest thing. Isn't it like the 2010 version?
Yeah, this is the 2009 one. Is what this is.
I don't know.
Yeah, this was a cool one. But in this case, they have this little jar of antimatter that when it comes into contact with regular matter, just it creates an intense amount of energy, and then
I want
that-
to say the black hole.
oh my god, I'm getting advertised. I need to get like just YouTube Premium on it.
Go, I got this. Go and install uBlock Origin.
Yeah. Where's I
It's
want to
the
know where.
best
Well, this is when they're like
adblocker.
destroying the planet. But anyways, yes.
Real quick, look up
We
uBlock
create
Origin.
antimatter. We actually it's very interesting. Antimatter by definition, right? The second it comes into contact with matter, instantly destroys itself and turns into energy. So it can become very hard, I guess, to even like measure antimatter because it doesn't exist for very long. Because the second it comes into contact with anything, it just annihilates itself. But
Yeah,
we do create it though, right? We have created antimatter in what, the Large Hadron Collider, right?
Yeah, I'm pretty sure because we measure the again, I'm not also an expert in I know significantly less about what's it called, particle physics than others. But yeah, like pretty much we see this splash effect of things that come into contact with one another, and then measuring the amount of energy and everything. If you add it all up, you realize that
We
like,
must
the
have
amount of
created
energy is
antimatter.
gonna be greater than if it was just the matter. So you know there's like something else in there. So because it like doubles the amount of energy, then we know that there's matter, antimatter, from my understanding.
Yeah, I'm not a super big particle physics guy, but yeah, that's I think what we know. I mean, probably like if I just type in antimatter into Google Images, like I'm sure something will come up. Antimatter, right? Yeah. Oh, that's cool. I didn't know antimatter is an antiproton and a positron. That's kind of cool.
Yeah. So electrons, what's it called? Electrons antiparticle is a positron, which is the same exact properties as what's it called, as electron. It just has a positive charge.
Right.
Now for an antiproton, which has a negative charge, has all the properties of an
electron. The charge of an electron, but it has the mass of a proton, right?
Yeah, exactly. Yeah, so proton is made up of quarks. There's 2 up quarks and 1 down quark. And then up quark has a charge of 2/3. Down quark has a charge of minus 1/3.
Okay.
And so the 2 ups plus 1 down equals like 2/3 plus 2/3 minus 1/3. So you get 1. And then the antiparticles of these would be anti-up and anti-down. So anti-up would be minus 2/3, minus 2/3, and plus 1/3. And then it adds to the thing. So actually, one of the coolest things, like this was something you actually kind of mentioned earlier, so now it kind of gave me an idea, is that how do we know that things are real out there? Like, we pretty much know that they're real to a certain degree, so that's pretty, like, evident. But one of the cool questions is, how do we know they're made up of matter?
Oh,
Because
okay.
they could be made up of antimatter. Because antimatter has all of the properties of matter. So if there's a galaxy... Yeah, exactly. So a galaxy could be made up of antimatter. And then the only thing that is different is the charge.
Right.
And then all of the laws of physics.
And then you wonder, like, but where's the boundary, right? Where's the boundary between the antimatter and the matter, right? You know, because it can't be a gradient, right? Eventually, antimatter and matter just annihilate each other whenever they have, like, a border, right?
Yeah, so we would only know if it's made out of antimatter for, like, something if it comes to contact with another galaxy that is made up of matter, and then they completely create, like, energy or something.
Yeah. That's crazy stuff. This would be, like, cool cosmology. Ripple has a question. How does a black hole give off light? Black hole doesn't give off light, right? We just went over that. It doesn't, right?
Yeah, so there is some sort of a radiation that comes with black hole.
Yeah,
and
this
has
is what's that radiation called?
Hawking radiation.
Hawking radiation. Yeah, that's right.
Yeah. So it's there to kind of um, balance out the information paradox, because we always say that there is no way that we will lose mass in the universe.
Right.
So-
Can't be created or destroyed. It's just transformed.
Exactly. So if it goes in and nothing comes out, then we're saying mass is destroyed. So we're
Right.
saying that there is some sort of a outwards like radiation, that this mass goes in, and then there's some sort, it comes out as some sort of radiation, which is essentially messing up the mass, right? It just throws out a bunch of random particles.
Mhm.
So we call that the Hawking radiation. However, to observe this is going to be really hard, because there's going to be a very small amount, and the only way for this to actually be observable is that there's nothing going into the black hole, so
Mhm.
we can kind of see the radiation kind of accelerate, right? Because actually it would have more radiation if it's smaller also. So like we will get into, like, I feel like this will segue into like a lot of stuff about black holes. But if we're talking about Hawking radiation, there is some sort of a radiation, but we haven't measured, we haven't observed it yet.
We just think it exists. We just says it must exist.
Yeah, I think mathematically it should exist, but we haven't made it an observation. Now, if you're asking about the light around the black hole, it's not the light that is coming from the black hole.
Right.
It's the light that is actually like going into the black hole, but it's just going at an angle where it like kind of goes around and like it like kind of shoots off.
Yeah.
Right? Exactly, like this. So it kind of like is getting close to a black hole, gets warped, and then shoots out. Yeah, exactly. So then that's what the light that is around the black hole. And it's also, some of it is also really heated up mass. So because things that are going near a black hole would
they'd feel the pull, right? They'd have a huge centripetal acceleration, right?
yeah, exactly. So because of the amount of speed that they have, they end up lighting up.
Uh-huh.
And that those lights that we see around it, it's like a kind of a disk, what we call. So that thing is called an accretion disk.
Ah, yes, an
Right.
accretion disk. Yeah.
Yeah, so then
Yeah. So we went over this last time, right? The pull, like the gravitational pull of something, causes it to have a velocity that goes around in a circle. That's
yeah.
cool. There was a recent discovery, actually. It was some woman or something, right? It was for her PhD thesis or something. She had this picture or something. It looks kind of funny. What was it? Do you remember what this is? Black hole picture. This was it.
Oh, like this actually, this came out during my exam on GR.
Oh, really? That's cool.
Yeah, this came out when I was taking GR. This came out. I remember it was at 9 a.m. and our prof, we were talking to a professor. We were like, hey, if the picture comes out and it's denying general relativity,
Do we have to take the exam?
yeah, do we have to take the exam? And then he was
a
like,
lie.
if it's like that, I'll like give you guys like extra marks. So like I'll give everyone like a whole bunch of extra marks. And then as the exam started, he was like, oh, the picture came out, physics still works. Good luck on your exam.
Good luck on your exam, dude. That's evil. Man, yeah, it was yeah, what was, yeah, I forget how. I think they showed like the number of hard drives
Yeah, it's
for
an
the data.
insane
It's an
amount.
insane amount of data they had to take.
There is a documentary on
Yeah, this is
on
it.
Netflix that talks about like the number of people who like worked on this and tried to render
Mhm.
like a picture finally out of this.
Yeah, they talk a lot about this. This is actually another, they love doing this. This is always the example of like women do things in science. Yes, girls go into science. Yeah, above here, who is this? Is this Margaret Hatcher or something?
Not Hatcher, but Margaret something. She's the one who wrote the code for
Yeah.
The first space.
The first space landing or something, right? Or moon landing?
No, I don't think it was landing. It was like a space travel something. I don't want to.
Mm-hmm.
Yeah, I'm not sure. But yeah, that's like the code.
That's the code. Yeah, yeah. So when she wrote code, she had to literally print it out on these like these punch cards and whatnot, and all this paper, and like that massive stack of that's all the code she wrote in order to like send us to space or whatnot. And then this is like the modern day version of a female grad student who took all these. It's like half a ton of like data in all these hard drives in order to make that cool picture. Yeah, Margaret Hamilton. Yeah. Oh no, it was apparently that took the first humans to the moon. Apparently, yeah.
Moon. Oh, okay.
Yeah, it was
I
for
knew
the
it was
moon landing.
space, but I wasn't sure about the moon part. But yeah.
Yeah, it's a cool picture. I remember seeing that. I was like, you go, girl. Like, what? That's a lot of code. Imagine like debugging that, dude. I'd like, fuck, dude. That would suck. Yeah, we're. This is. Yeah, look at it, dude. This is all our data, dude. What? An insane amount of stuff. Imagine, dude, like, like all the environmentalists or whatnot and be like, that woman killed so many trees to burn all that gasoline to go to the moon. Can't have that. Oh, man. Super cool. Yeah. Yeah. Apollo guidance software they developed at MIT.
Yeah, Apollo.
It's almost as tall as she is. I guess it's almost, yeah. That's a lot. Crazy. Okay, let's wrap it up with like one or two more questions. And it's almost been an hour and a half here. Ethan says, what is moles in science and why are they important? That's cool. Not a hard one. Let me think. I want to go to here. Okay. Moles is a convenient way of describing the number of things, is what we say, okay? So, you guys know, for instance, like 1 dozen. How much is a dozen? Like a dozen eggs. How many eggs is that? I know someone did it. Ika, what's a dozen? How many are in a dozen? Please tell me you know how many.
12.
Thank you. Okay, good.
If Teacup didn't know, I'll be surprised.
I was starting to worry.
He's figuring out all these like
these puzzles, right? In the chat.
I don't know what's going on, and then he's like, I don't know what a dozen is.
I don't know what a dozen is, dude.
What the does? Isn't it like
I feel
11?
I feel like this kind of dude, like with Noise is so smart with all the math stuff and whatnot, but then he's like, he can't be fucked to do chi-square tests. I'm like, what? Bro, it's so much easier.
Yeah.
Yeah.
But I honestly
yeah.
relate to his experience because when I was like studying, I would be like interested in the things that I liked, and then it didn't like the difficulty of courses almost like didn't matter. Like I actually, my lowest marks in math were stats because I hated stats.
Wow, it's just like you're just like I can't be fucked. You're like I know I can do it, I just don't want to.
Yeah, I just was like, what's the point of this? I like didn't go. I went to like one stat lecture, and like I stayed like 5 hours in total for my like stats course, probably. Like, yeah.
You said you hated it because of stat mech, like having to do microstates and macrostates and all that shit.
That was StatMech was afterwards. It just grew my hatred even more.
Grew your hatred for stats, dude.
It was always a downhill with stats.
That's so funny, dude. I love stats. I feel like stats is one of the coolest things.
I like it now.
I think it's arbitrary, honestly. It is interesting that we just came up with these like these rules, right? Like the bell curve and whatnot. We're just like, yeah, these are just rules. Like, okay.
I think I ended up working with the applications of stats like after, not having to take like boring courses. So now I like stats more. I wouldn't say it's like my favorite, but I no longer have a hatred for it.
Right.
But it's definitely
it's a cool thing. Yeah, I think stats.
But yeah, it's definitely I can see the use for it now.
Someone ever wants to ask about stats, I would gladly do a little stats mini lecture. I do like stats. All right. Cool. So yeah, Ethan, a mole is so like 1 dozen is 12 things. A mole is 6.02 times 10 to the 23 things. So that's like 6 with 23 zeros after it, which is like a very big number, right? It's huge. Okay. The reason why we use this number moles is because if you've ever looked, for instance, at the periodic table, let's see.
I've seen the periodic table.
Right, I'm sure you've seen the periodic table.
I
if
have
we
a
do-
copy of it.
Let's see,
And it's
periodic
atomic numbers.
periodic table. Um,
Coming.
There we go. This is what I want. Picture of her. Can I copy this image? Oh, it's an SVG? Okay, whatever. All right. You guys can see here. Do you see how there's like numbers here? This is what we call the atomic weight, right? The atomic mass.
Yeah, atomic number and atomic mass. I know what I'm dealing with.
Good. Very good. Okay, yeah. Atomic number here. This always says the number of protons. This is like the weight of something is what it is. But you may be wondering, like, okay, well, what are the units for that weight? Like, what is our weight in? Okay. When we say, for instance, like the atomic mass of carbon is 14, okay? Really, what the units for this?
Isn't carbon 12? Wait, hold on. Isn't carbon 12?
No, you're right. You're
Nitrogen
right.
is 14.
Yeah, you're right. Carbon.
Or you could say nitrogen.
There can be 14.
Yeah,
it's called
isn't
carbon 14, right?
Yeah, there's an isotope for it, right?
Yeah, we can go into isotopes and whatnot. Yeah, the carbon 14 has like 2 additional neutrons, is what it has. But okay, the standard atomic mass of carbon is 12, right? Then what we say is that that's equal to 12 grams per mole, okay? Which is the same thing as saying for 1 mole of carbon atoms, that would equal 12 grams, okay? So if you have 6.02 times 10 to the 23 atoms of carbon, that's how tiny an atom is, right? You need like something with 23 zeros to equal 12 grams of it. That's why we use moles, because we use moles to describe things that are down at like the atomic level and whatnot, like atoms and whatnot, but we need to be able to also work with them at the human level, you know, of things, you know, grams, inches, centimeters, and whatnot. Yeah, this gets into.
But I have a quiz on that tomorrow.
You have a quiz on it? Okay.
Yeah, tomorrow.
Always good to ask those questions. Those are examples of questions, Ethan. If you have difficulty understanding stuff, that's what you should ask first during office hours. Like, ask. You know, I like the cool challenge problems and whatnot. But if something with moles doesn't make sense to you, like, ask that during office hours, so I can at least help you. Like, because there's a bunch of different ways that you can use moles. We can use it in chemistry for like, you know, mole fractions and whatnot. You can use it in thermodynamics. You can use it in a lot of things. Just depends what you're getting tested on. This goes into another like kind of cool topic. Do you know about like Planck length, Ramton?
Planck clank?
Planck length? Planck length?
Oh, length. Okay, yeah. I heard
length.
clank.
Clank clank. Planck clank. No.
Yeah.
Planck length, right? They kind of say this is like the reason why we're living in a matrix, right? We live in.
Yeah, because there's a minimum length.
Yes, and by virtue of there being a minimum length, because things can only travel at the speed of light, right? That gives you a minimum time, right? Or like a refresh rate on the universe.
Yeah. So that's the Planck time.
That's the Planck time. Yeah. And I think this comes down to the uncertainty principle, right? Is that where Planck length and Planck time comes from?
And I forgot where they come from, but they do appear or Planck length does appear in the what's it called? Entropy of a black hole.
Okay.
That's also a cool thing that we can talk about, like entropy, like how to come to a formula is like, you know, obviously we're not gonna get into it, but like that's also another cool thing. Oh yeah, it's right there actually. It's
Oh wait, was it the third one? Sorry.
Yeah, like you see the square root of.
Oh, this one right here. Okay.
Yeah, so it's like an equation that pretty much connects all of the
Oh, it's the unifying theorem. It's like the big reunion party.
Yeah, exactly. Because it's like H comes from quantum,
yes.
G comes from gravity, and C comes from general relativity or relativity.
Oh, wow, this is the party, dude. The party. Yeah, this is always I think this is always a very cool thing in physics. They're trying to unify, right, all the theories, because we have all these different fields of physics, and like they should be self-consistent, right? They should agree and play nice with each other.
Yeah.
And that's cool. That's where, like, you know, that's let me see if there's like a nice little diagram of this. Yes, any length shorter makes no physical sense, but I think it doesn't make any. Why does it not make any physical sense? Oh, maybe it's okay. Maybe it has to do with the vibrations of like the particles. I think it does. I think this does eventually come down to something in terms of uncertainty principle. Like you can't measure like distances without like there's an uncertainty to it.
Yeah, that makes sense. Yeah, this is like the most bullshit explanation ever, dude. Like what? Like why? Yes, but where does it come from? Where does it come from? I think there's a much nicer way of describing this, but
We can do it.
I either have come across it very briefly or don't remember.
Yeah. The main thing to know, you guys, is that there is a you know, like on a ruler you have like so many, you know, what's the smallest length you can measure in the universe. Like there's a smallest distance you can measure with anything, and that's what they call like the Planck scale. And from that, because that's a length and you divide it by velocity and whatnot, you then get a Planck time, and that's the shortest amount of time that two things can like differ in, which you guys probably know from video games is the refresh rate of like a monitor. You guys have probably seen like buying a monitor that's like 144, right? Or 60 hertz or 75 hertz. You've definitely seen it if you get FPS, right? If you PC gamers out there probably see like how many FPS are you getting, right? That's how many times your screen can refresh in a second. Like the same thing happens in the universe. Like there's only the universe, while it's a very, very, very high refresh rate, there is eventually like there's like a flicker in like what things are happening at. It's cool. It to me it analogs that like, oh, we must be in like some sort of simulation, because like what? There's a refresh rate. there's a time to the next frame. That's super cool. I need to find that book. I think, you know what I think it is? I think it's The Universe is Virtual. Yeah. Oh, this is one of them. This is a pretty. Have you read this book before, Ramton?
What is it?
The Universe is Virtual.
No.
It's pretty cool. I had a friend. It goes more into like consciousness, I guess. There is physics. I mean, they do explain, like, for instance, what's the information paradox, where like they put the cards in, then they open the box and they're like, oh, this card's black, this card's white, or something.
Oh, is like the Schrodinger's cat?
Schrodinger's. Yeah, it's it's like that. Yeah. But it goes into some pretty cool physics topics, but it's a comic book, is what it is.
Oh,
so,
okay. That's
here.
pretty cool.
Yeah, I remember reading it at some point. A couple of my friends who aren't in physics like were reading it, and they're like, "Oh my god, this blew my mind!" And then I read it, and I was like, "Oh, it's kind of cool, I guess." Like, probably has some pictures of it, how it is. Yeah, it's like this. It's a comic. But there's some cool information in it. I will remember the name of that other book about the computer like realizing like what humanity is or something. Okay, cool. Let's see. Do we have any last questions? It's almost point. PH Penguin says, "What is the most important lesson you learned in life so far?" Wow. Oh, that's a. Oh man. I've learned too many lessons. That's the problem, honestly. Like I learn a lesson every day. You know, I teach lessons every day too. But most important lesson I've learned in life, probably perseverance. Honestly, that's the most important thing I've learned. You're not done when you're defeated. You're done when you quit. It's kind of That's been a big lesson I've learned is that
That's a good one. I like
Right.
that.
yeah, perseverance is one. It's just like just keep trying. Like you're always gonna get met with things where you're like, oh shit, like this isn't working, I should quit and whatnot. It's like nah, you just gotta like keep. There's that cool. Have you seen that one with the diamond mine guy or something? Where is it? One sec. It's images. Diamond mine. Don't quit. Don't give up. I know it's this one. Yeah, it's this picture. They love this picture.
Oh, I actually have a cool idea as well. I thought that one thing we could do is we could add a channel, like one of the pages on the Discord,
Yeah.
and people could put like cool life quotes.
Oh, I like
And
that.
we
Like
could-
yeah, like
we could-
inspirational
we could
stuff.
End the streams with like one of those, and like if we have one of our own, then we could put that. Or if someone posts like a cool one,
Mm-hmm.
you can like end the stream with like, and then like this quote, and then
I like that.
It could be like a giveaway every like week or something.
Yeah, who's got the coolest life quote? Yeah, I like
Yeah.
that. That's a good one. Yeah. This picture it illustrates what I think about like just don't quit. Like some people will get so close, like you're almost at success and whatnot, and they just like give up at the last second. Whereas like this guy's like hopefully just gonna keep going. You'll get to the diamonds. Just don't give up. Don't quit. I know things can always seem like they're down. I mean, apparently Mercury's in retrograde right now, which I definitely feel because like everything's breaking. My kitchen light just broke for whatever reason. I'm trying to like cook in the fucking dark. I'm like, God damn it. But yeah, that's my number one lesson. Ramton, what's the most important lesson you've learned in life?
You
I know.
you had a good one, because I feel like that's pretty much.
It's a pretty good one. It's a pretty
Oh,
good. Universe.
actually,
What's the second best one? You can say the second best one.
Actually, this was actually I've heard the similar quote from different like philosophers or something, but it was saying that the pursuit of something that is like success is not certain in life, and the thing that makes it like precious is the fact that we pretty much follow our heart to like success, even though we know it's uncertain.
Right.
So like the satisfaction that we get from just pursuing that is what makes life worth living itself, rather
Not the
than-
success itself.
Not the success itself.
Yeah, I like that. Yeah. Like it's like learn to enjoy the journey. Like the journey is the best
Exactly.
part. We're all trying to get the ice cream or the whatever the top of the mountain, but life is enjoyed in the journey on the way there. Yeah, and I think life should always be a constant journey. Sometimes I guess we look at, all I have to do is finish high school. All I have to do is finish college. All I got to do is get through med school. And then you feel like you're gonna come to some like realization of like, oh, I'm at the top. I'm done. I've got it. I got the success. But in reality, like life should just be you're just constantly learning. You should constantly be like chase the chase of something is what makes it worth it. It's like that's the whole part of it. That's life. Yeah. Oh, that's cool. I like that one too. Beef says, is Golden Hour going to be a weekly thing? Yes. Yeah, hopefully we'll keep it going. Yeah, every Thursday. I'd like to do it. It's golden hour and a half.
Yeah.
It's all good. All right, we try to make it an hour. That's an hour and a half. We got 10 viewers in the Twitch. What's up, Twitch? Good to see you guys. I appreciate your presence and whatnot. Okay, cool. Let's do another giveaway to end off the stream here. Between questions and whatnot. We'll do include me. Not gonna lie. Teacup, you've already won. you already won today.
I can't win again.
You can't win twice. Here, let's do this. Let's do because I liked your idea of Ramton of doing like categories that like we maybe we pick one from each category of questions, right?
Ooh, okay, that's cool.
Like I like what were we thinking they were gonna be like science, right? Social, and then I don't know, maybe just like random.
There was like math, physics, or math, science, and I think like for this time we didn't have a lot of math questions, so
Yeah.
I said math, science, and social.
Yeah.
But I feel like this time it was pretty sciencey. I like the questions actually; they were really good.
Yeah, there's some good ones. Yeah.
I
All
feel
right.
like
Cool.
we can do science and social.
Yeah. Let's do a science and a social. Here, you pick the science one. I'll pick the social, and then we'll do a we'll spin between the two to see like who wins. I like that. That's a cool one.
Okay.
Hold on.
How many am I gonna?
You pick two. You pick two science. I'll pick two social.
Two science. Okay. Teacup had a really good question, but because he already won, no, I gotta give the opportunity to other people because it's already a hard one.
Yeah.
But-
It's
For
already,
the meme, after you
I'm
spin the
giving
wheel,
you the
put me in to see if I would
recognition
win.
Yeah, I'm giving you the recognition that you deserve. Because
Yeah, you do deserve it,
was a
dude.
good question.
It's good.
Ooh. I would say one's Riplaw. He had two questions. I really like both.
Okay. Riplaw's in there. Riplaw asked about, what did he ask about? Was it black holes, I think? Was that the, I'm trying to remember what he
yeah,
asked about.
he asked about black holes one time and another one about like the astronomers in space. I think they were both really good questions because it's really thoughtful actually. I feel like he's asking really good questions. You're not asking them specific enough, and I think that comes from the fact that obviously
Yeah, they're
you don't
young.
have
They
to
just,
know-
they don't really know as
Yeah,
much.
if you once you learn more, then these questions become more specific, and within each of the questions, there's like multiple questions itself. So
Yeah.
I really like those. And then the other one, I think because Ethan, I've seen him around a lot of times.
Uh-huh.
I'm like, you know what? I'll give the chance to OP Black because has Ethan won anything?
I don't think for the giveaway he hasn't. He wins at Fortnite a lot. I'll give you that.
He wins Fortnite. Okay,
Yeah.
so I'll do OP Black.
Okay. OP Black, you're in for it.
But also Ethan's questions were.
Ethan, we liked yours too. Let's see.
Yeah, we all know.
Fine, in case I'm dropping anyone.
You're good. Don't
Yeah.
worry. Again, yeah. This. It is too funny when I give things away. People get like mad, and I'm like, just be happy that there's anything. Like usually people don't give away anything. You should see when I would do the big prizes, when I start giving away laptops and whatnot, it becomes like I'm like, please, like no gloating, no getting mad. Like,
Don't you dare go there.
yeah, please don't go there, anyone. Please, like, let's just be happy that Dr. Gold's giving away his rent money to you guys. Okay. Social questions. I liked THY Penguins. I liked his question about what's the most important life lesson. It's always a heavy hitter. That's a good one. What did someone else ask? I'm trying to think.
I say at least I tried to
Yeah,
get
of
a good
course.
question in.
Yeah. No, we're not saying your question was bad. We're just saying there's also other questions are asked. Yeah. No
But
one.
Habib also, I see. I just.
I
saw
like
Twitch
Habib.
that he said- Yeah.
Habib did ask a bunch of like riddles, which were fun. Habib, I'll put you in there just because it was interesting to like see all the things you're doing. Yeah. Okay. Cool. All right.
What if you would have put me in there?
But I can only put 4. He says, "What do you put me?" Also, this one's for Discord
didn't hear
Nitro. We so the middle prize we do is $10 gift card, whatever. The end of the stream prize for best question is Discord Nitro. Until if all you guys have Discord Nitro, then I'll come up with a new prize. But I don't think anyone here has Nitro, so you know this is a good gift for you guys. I know Noise really loves Nitro. It's cool. You can upload stuff and whatnot. All right, let's see who this goes to. Bum bum bum. Who's gonna get a month of Nitro? Who's gonna get it? Oh, it's THY Penguins. Good job, THY Penguin.
With that, he hit that with the buzzer question.
Yeah, he did with the buzzer question, dude.
He asked the question earlier, actually.
He asked it
I
twice,
think he-
actually. I think he asked it twice. He asked it
okay.
once. He asked it at the beginning, then he asked it again, and I was just like, okay.
Oh,
So
okay.
congrats, THY Penguin. Yeah, nice. Okay, awesome. Okay, thank you very much, everyone, for coming to the Golden Hour. A lot of fun with you guys. Some great questions. Like, keep it up. We're gonna do this again next Thursday. You know, if you're just like going around your day and whatnot, and just wondering about something, write it down. You know, ask it during the stream. We're here to help you out.
Is this gonna be weekly?
Yes. Yeah. I mean, this is the 3rd week we've done it, right? So I think it's almost weekly at this point.
Yeah.
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 Almost a month.
Yeah. It's supposed most people, they have all these other channels on Twitch where you just got like chicks sitting in hot tubs and just like talking about things. I'm like, let's get like two, nerds up here and we'll talk about life and science. I think that's cool.
Yeah.
A little bit more intelligent. Yeah,
We gotta get rated by one of those streams.
Oh my god, you imagine? I'm gonna be like, dude. I remember me and my one buddy used to sometimes do like joke hot tub streams. Like it was just like we called it TGIATH. It was like three guys in a hot tub, and we would just sit there and just like answer questions. But then like you do start getting some like strangers like that find your stream, and then they start trying to like donate bits for you to show your feet, and I'm just like, no,
Yeah, I feel like
no.
the demographic that it attracts is not.
Yeah,
gonna
it
be
does. Hopefully
I
this
think
is.
not everyone takes it as a joke that it's supposed to be.
I know, but then like some dude donated like 500 bits. I was like, that's like $5. I think we have to at least show like a big toe or something. I don't know. Anyways, yeah,
Alright.
this is cool. I like the idea of Ramton's idea with the quote. I like the quote idea. Actually, you know what we should do? At the end of the stream, we'll do a giveaway and we'll have like the wild card entry be whoever had the best quote from the week. If you found the best like inspirational quote or whatnot. I like that. That's a cool idea.
Inspirational quote.
But like don't spam it with like 1,000 quotes. Like try to like.
Or you can, as I said, I think you can make like a channel on the Discord.
Yeah, I'll make a channel on the Discord. Yeah.
And then people could put their submissions, and the best ones could like get bond coins or something. I don't know.
Yeah.
How coins.
Yeah,
that
no.
could be in there.
Yeah. Nice. Okay, we'll do. Ramton, any last words before we finish this off?
No. I hope
Okay.
everyone enjoyed.
Mhm.
Everyone asked.
Yeah, let's give it
Good
up Ramton. Ramton had some great descriptions of black holes and whatnot. I learned a lot actually myself. I'm not the smartest person in everything. I don't understand everything. So like, I appreciate that. That was cool, Ramton. I learned a lot.
Yeah, I want to get people.
Get them hyped.
Yeah, ultimately I want to do like this is like my major job and everything.
Yeah.
So I'm getting definitely. If there is obviously demand for it, then that just gives me more motivation to kind of
Yes.
stick.
Yes. Yeah. You guys are the reason. Like, if nobody showed up to this, I would still do it, but I wouldn't feel as excited. So like, know that I really appreciate you guys showing up and your input and participation. Like, it means a lot to us. It forces us to keep doing it even, or it doesn't force us. It makes it more enjoyable. Like, I look forward to it more.
That's the goal.
Yeah.
That's the goal.
What's up?
Those exact same words I would want to say to you because you don't know how much you changed my life. Okay.
Oh, fuck, man, dude. I appreciate that, Ethan. I really do. That's the whole goal here. I'm glad. I'm glad to help change your life. That's sick, man. Yeah. That helps me a
I
lot.
can't thank you enough.
You thank me every day by just showing up and keep being you, dude. That's the best thing, Ethan, dude. That's the best gift you can give me back.
Fun.
Fine then. Yeah, you're good. All right. Thanks everyone. Tomorrow's stream, if you got homework questions, we're going to be answering them on the office hours stream. That's going to be at 5 o'clock Pacific, 7 o'clock Central, 8 o'clock Eastern. And then afterwards, we got recess for an hour. We're going to do Roblox. Have you guys picked the game? Maybe we'll do Doors again. I don't know. Doors is always fun. But I'm always down to switch it up. So if you guys got a cool Roblox game you guys want to play, let's do it. Thank you everyone for coming. Make sure you join our Discord so that you get all the announcements for when we do these types of streams and whatnot. And so that we can help you out. Maybe change your life a little bit. We're down. So that's the Discord. And then if you ever need the schedule for the Twitch, that's the Twitch schedule as well. Okay. All right. Thank you everyone for coming. I will see you guys on Friday. Have a wonderful rest of your Thursday. And we'll
Have
see
a
you
wonderful
then.
rest of your Thursday as well.
Thank you, Ethan. I appreciate it, dude. I really do. All right. Peace
I
out,
say it
guys.
goes for Remington as well.
Yes, Ramton's awesome. We love Ramton.
I'm glad to help. Like, yeah, it's good to hear that.
All right. I'll see you guys out.
Good night,
Peace.
everyone.
Good night.